Question 11. We've got to find the values of the constants a, b and c in the above equation. So the first clue is that we've got a top-heavy fraction here. So we've got an x squared here and we're going to get an x squared on the bottom as well. This is also shown by the fact that we've got a constant on its own. So we're going to have to do a bit of algebraic long division. So to begin with, we're just going to look at expanding the bottom of that fraction. So we've got x minus 3, 1 minus 2x. So that's going to give us x minus 2x squared minus 3 plus 6x. So we've got minus 2x squared add 6x, so that's going to be add 7x minus 3. And so dividing that into minus 6x squared add 11x add 1. So minus 6x squared divided by minus 2x squared is going to be 3. And so multiplying that through, we get minus 6x squared. 3 lots of 7x is going to be 21x. And 3 lots of minus 3 is minus 9. So this is going to give us minus 10x plus 10. And so we've got 3 wholes. And then we've got add 10 minus 10x, which is still divided by x minus 3, 1 minus 2x. So we're now just going to focus on the second part here. And we're going to say that this can be written as 10 minus 10x is equal to a over x minus 3, so 1 minus 2x, add b over 1 minus 2x, so that's times by x minus 3. Set x equal to 3 to begin with, nice and straightforwardly. And so what we can do is when x is equal to 3, we are going to get that 10 take away 30 is minus 20, and that is equal to the b part gets zeroed, and so we've got minus, if we're x equal to 3, 2 3s are 6, 1 minus 6 is minus 5, lots of a, and so a is 4. And then if we set x equal to a half, then we're going to get 10 minus a half of 10, so we're going to get 5. The a part here will be zeroed, and we've got a half minus 3 is minus 5 over 2. And so therefore we get b to be minus 2. So our values then are going to be 3 plus 4 over x minus 3 minus 2 over 1 minus 2x. Part B. Prove that fx is a decreasing function. So if that is fx and we want to prove it's decreasing, what we need to do is we need to look at the differential. So f of x is equal to 3 add 4 lots of x minus 3 to the minus 1 minus 2 lots of 1 minus 2x to the minus 1. F dash x, therefore, the 3 disappears. Using the chain rule, we can say we've got 4, because that constant stays. Power comes to the front, minus 1. Differentiate the bracket, and that goes at the front, 1. Bracket stays the same, take 1 off the power. So then take away 2, lots of power comes to the front. So if the power comes to the front, we've got minus 1. Differentiate the bracket, we get minus 2. Bracket stays the same, 1 minus 2x, take 1 off power, minus 2. So this is going to give us 4 times minus 1 times 1, so we've got minus 4 over x minus 1 squared. And then we've got 3 triple negatives there, so that's going to be minus 4 over 1 minus 2x squared. What we know is that x minus 1 squared must be greater than or equal to 0. Let's just check any limits. We've got x is greater than 3. So as x is greater than 3, we know that that must be strictly greater than 0. We know that 1 minus 2x squared must be strictly greater than 0 as well. So therefore f dash x must be less than 0 because you're going to have a negative and a negative. As f dash x is always less than 0, it is a decreasing function.